Hello guys, my name is Josephine Cornelius. You can call me Sir Joseph. I'm a math teacher in John Paul School. Now I'm here to teach you and give explanation about angles in geometrical figures. Okay, the first we learn about 2 points that's really important. In point number 1, 1A, AOB is a straight line. You may see this one A, this one O, this one B. And then find the angle of A. To find the angle of A, you need to memorize this statement. The sum of angles on a straight line is 180 degrees. So, when you see AOB is a straight line, to find the angle of A as equal 180 degrees, because the sum of angle on a straight line is 180 degrees, minus 25 degrees from this, and then minus 90 degrees, because when you see this angle, this is called right angle. So the right angle is 90 degrees. Then you input this one minus 90 degrees. And then when you calculation, the angle of A as equal 65 degrees. We go to the next point, 1B. AOB and COD are straight line. Find the angle of X. You need to memorize this law or statement. Vertically opposite angles are equal. So if you see that AOC as equal 41 degrees, and then the angle of X or BOD, this is vertically opposite angle. Meaning, if AOC equals 41 degrees, then the angle of X as equal 41 degrees as same as the angle of AOC. Okay, now we go to the next statement. In the next statement or the other law, 1C, find the angle of Y. To find the angle of Y here, you need to memorize this statement or this law. The sum of angles at a point is 360 degrees. In this question, you may see all the lines meet at a point O. For example, you see the line of TO, you see the line of PO, you see the line of QO, you see the line of RO, and you see the line of SO. All meet in the angle or point O. So meaning the total angles here 360 degrees. So to find the angle of Y as equal 360 degrees minus 70 degrees from this, minus 88 degrees from this, minus 65 degrees from this, minus 73 degrees from this, as equal 64 degrees. Okay, that's the point 1. It's easy, right? Now, let me introduce the point 2. In the point number 2, you learn about kind of triangle. We start in 2A. ABC is an equilateral triangle. Find the angle of B. First thing first, you need to memorize the law that the sum of angles in triangle is 180 degrees. As you know, we can see 3 angles in triangle. And then in this case, because equilateral triangle, you need to memorize this law. An equilateral triangle has 3 equal sides and 3 equal angles. The size of each angle is 60 degrees. Why? Because equilateral triangle has 3 equal sides and 3 equal angles. So to find the angle of B, you can do this calculation. 180 degrees divided by 3, because equilateral triangle has 3 equal sides as equal 60 degrees, and also has 3 equal angles. After that, if you see angle of ACB here 60 degrees, CAB 60 degrees, then to find the angle of B or the angle of ABC as equal 60 degrees. So the total the sum of three angles in triangle is 180 degrees. Next, we go to the next point. The next kind of triangle, it's called isosceles triangle. DEF is an isosceles triangle. The angle of FDE, first you need to identify the angle of FDE. As simple as this. You see the capital letter F, D, E, meaning the letter in the middle is divine the angle itself. So FDE, you can put 48 degrees in here, and then the angle of E, this one the small letter, as equal angle of F. Find the angle of E. To find the angle of E, you need to memorize this law or this statement. An isosceles triangle has two equal sides and two equal angles. The angles opposite the equal sides are equal. So, in this case, you may see that the side FD as equal the side of DE. No wonder we can say the angle of E plus the angle of F as equal 180 degrees minus 48 degrees from this, the 48 degrees, as equal 132 degrees. So the total angle of E and F is 132 degrees. And you know, the law told you about isosceles triangle has two equal sides. In this case, the angle of E as equal the angle of F. Then, to find the angle of E as equal 132 degrees divided by 2 as equal 66 degrees. Meaning, if you put the angle of E 66 degrees, following the angle of E, the angle of F also 66 degrees. Okay, now we go to question C. The law in question C, the statement, we learn about kind of triangle, right angle triangle. Okay, the right angle triangle. You may see from the question, JKL is a right angle triangle. The angle of JKL as equal 55 degrees. Remember how to identify the angle of JKL? You may see the letter in the middle. So, JKL. After that, you put 55 degrees in here. Find the angle of J. This is in small letter. So, to find the angle of J, you need to memorize this statement or this law. A right angle triangle has one right angle, which is the angle of JLK in here, and the sum of the other two angles equals 90 degrees. Do you know why? As you know, from the 2A, you learn about the sum of angle on triangle is 180 degrees, isn't it? So meaning, if this is right angle as equal 90 degrees, 180 degrees minus 90 degrees as equal 90 degrees. So, the sum of other two angles equals 90 degrees. Does it make sense to you? Yes, it does. So, after that, to find the angle of J, as simple as this. Equal 90 degrees minus 55 degrees from this, and then as equal 35 degrees. So this one, the angle of JKL plus the angle of J itself must be 90 degrees, right? So when you check, let's do checking. If you check this one, 35 degrees plus 55 degrees as equal 90 degrees is proven, right? Proven. Okay. So that one, the material that you need to memorize, that you need to know, is about the law in angle of geometrical figures. Now, what about I give you two questions to make you really understand the material that I shared before. Okay, let's see the first question. In the first question, in the figure, ABD and CBE are straight line. ABD here, you may see from this, ABD and CBE are straight line. And AE, this one, the side of AE equals the side of ED here equals the side of CD. The angle of ABC, remember how to identify the angle? You see from this. Okay, so ABC, you put 133 degrees here. And the angle of DCB, remember how to identify the angle? You see from the letter in the middle. So DCB, you put 24 degrees in here. Find the angle of AEB. You may see from the question already marked angle. So AEB in here. This is question mark. Now, to find the angle of AEB, you already learned about the law in geometrical figures, right? Angle in geometrical figures. So, first thing first, you need to identify. In this case, I will make it clear first, yeah. So, if you want to find that, remember the law in 1b that vertically opposite angle are equal. So, from this, we know that the angle of EBD as equal the angle of ABC as equal 130 degrees. This is called vertically opposite angles are equal. Okay, next, after you know from this 133 degrees, now you may see from this ABD is a straight line, isn't it? Then to find the angle of ABE, you must memorize the point 1a. The law of the sum of angle on a straight line is 180 degrees, right? Then to find the angle of ABE, because ABD is a straight line, so 180 degrees minus 133 degrees. So you can do this calculation, 180 degrees minus 133 degrees, 0 minus 3 you can borrow, this one into 10, this one into 7, 10 minus 3 is 7, 7 minus 3 is 4, 47 degrees. Okay, this one as equal 47 degrees, why? Because ABD is a straight line. Okay, after you get this one 47 degrees, now you may see from this, these two angles from the triangle of AED, you may see that one is called isosceles triangle, right? And then because of this one also as equal 47 degrees. Nah, so the angle of CBD as equal 47 degrees. Yeah, because vertically opposite angles are equal. I put in here, yeah, vertically opposite angles are equal. After that, you may find this angle. Okay. or you can directly find the angle of ABE based on this triangle, because the triangle of BCD, let me write down here, triangle of BCD is an identical triangle of triangle ABE. Meaning, because of this statement, as you know, the angle of EAB as equal 24 degrees, right? Then the last step to find the angle of AEB, because this is 24 degrees, so you may see the triangle of AEB, that one triangle, right? Remember the law in the law of 2A. 2A, the sum of angle on triangle is 180 degrees, right? Then to find the angle of AEB as equal 180 degrees minus 47 degrees minus 24 degrees. As you know, 180 degrees minus 133 degrees as equal 47 degrees, meaning 180 degrees minus 47 degrees as equal 133 degrees, right? Then we can count this one, 133 degrees, you minus with 24 degrees, minus it. Subtract after that, 3 minus 4 cannot, borrowing into 13, and then this one borrowing into 2. After that, 13 minus 4, that one must be 9, and then 2 minus 2, 0, and then 1, don't forget to put down the 1. So this one as equal 109 degrees. So we find the result, or we find the angle of AEB as equal 109 degrees. It's easy, right? I think you don't have question about it, right? Now let us continue. We go to number 2. In the figure, ABCD is a rhombus. BCF and DCE are straight line. The angle of ABD equals 80 degrees. Find the angle of X and the angle of Y. To find the angle of X and Y, first thing first, don't forget to identify that the triangle ABD, you see the angle of ABD here, 80 degrees, meaning the letter in the middle, 80 degrees. Then, because ABD, you see, BD is a line symmetry, and then the angle ABD, 80 degrees. So, the triangle of ABD, what do you call is that? Correct. The triangle of ABD is an isosceles triangle. After that, because this one 80 degrees must be following, right? So the triangle of ABD is an isosceles triangle. Then you can find the angle of ADB. The angle of ADB as equal 80 degrees. Or if you forget, remember the angle of ADB as equal the angle of ABD, which is equal 80 degrees. Okay, now when you see the triangle ABD is an isosceles triangle, isn't it the same with triangle BCD? Yes, for sure. So the triangle of BCD is an isosceles triangle. So from this, you know that the angle of CBD is equal the angle of CDB as equal the angle of ABD. So 80 degrees. So this one you can put here 80 degrees for the angle CDB and the angle BCDB and the angle of CBD. Okay, from this, because BCD is an isosceles triangle, remember the law in point 2A that the sum of angle in triangle is 180 degrees. So it's easy for us to find the angle of BCD. BCD is equal 180 degrees minus 80 degrees minus 80 degrees. 80 degrees from this, 80 degrees from this, right? Okay, then as equal 20 degrees, because 180 degrees minus 80 degrees as equal 100 degrees, right? 100 degrees minus 80 degrees as equal 20 degrees. So the angle of BCD as equal 20 degrees here. Remember, BCF and DCE are straight line, right? You need to apply the law of 1B, point 1B, that vertically opposite angle are equal. So we can find the first angle X as equal the angle of BCD as equal 20 degrees because of vertically opposite angles are equal. Okay. After that, to find the angle of Y here, you know, you can use the law of point 1C. In the law point of 1C, the sum of angle meet at a point is 360 degrees. In this case, the point is point D. So, to find the angle of Y as equal 360 degrees minus 80 degrees from the triangle ABD, you can take the angle of ADB minus 80 degrees, this one from the angle of BDC. Okay, now you can count that 360 degrees minus 80 degrees as equal to 180 degrees, right? So 280 degrees minus 80 degrees, this one 0, 0, and 200 degrees. So the answer is 200 degrees. This one is because the sum of angles meet at a point is 360 degrees. Okay, guys, that is for today. I hope that you can understand the concept of angles in geometrical figures. Then, hopefully, you can practice as well at home, so you can answer all the questions from the angles in geometrical figures as well. Okay, thank you and God bless you.